by this rule when they're adding here, you can't do that, okay? If this is being multiplied or divided in here, you can use this rule. If it's adding or subtracting, you've got to write it out twice and multiply it. So this means x squared raised to the third, which is x to the sixth, and then you also have to raise y to the third, so then just y to the third. Okay, so this is kind of how we did it in Algebra 1, if you can remember back that far. Now we're going to have some exponents with fractions. Okay.
One second.
You're fine.
Okay. Am I though?
I'll also erase this half. Alright. I don't know. I didn't even title this.
What?
Did you say my name?
No, I said A. Wait, it's A. It's A now?
A now?
What?
You're an all-star.
Wait.
A bye. I win.
Is this gonna be like multiplying fractions?
It's going to be like adding fractions.
Oh, okay.
Which is
Well,
harder.
same
actually.
difference.
Multiplying fractions is easier. Okay, so what did you tell me the rule was? You add the exponents. You can only add them if your base is the same, right? The base has to be the same. Then we add the exponents. So this is, you can either write equals or you can, I'll work it this way. All right, so this would be 7 to the, you don't have to write this step if you don't want to. 1/4 plus 1/2, okay? When you are adding fractions, yes, like denominators, you say common denominators. One of the, so you have to have the bottom number be the same. So to get 2 to be 4, we multiply this by 2 over 2. And then we have, I'm just gonna work this fraction out. 1/4 plus 2/4. Anybody struggling with this step right here, what I just did? Fraction, yes? Okay, so when you're adding fractions, the bottom number has to be the same. And you have to figure out what can I make both these numbers into. Sometimes you have to multiply both of them. In this case, we could just multiply 2 by 2 and it becomes 4. That's how we can make it 4. And whatever we multiply the bottom of the fraction by, we also have to multiply the top by that same number. So that's how we got this to become 2/4. Now when you add them, you just add across the top and it's 3 over 4. So with adding and subtracting fractions, you only combine the top. You don't change the bottom. When you're multiplying, multiplying is the easiest because you just multiply everything straight across. You don't have to change anything or mess with anything. Okay, so this is now 7 to the 3/4.
What if the base is the same?
Huh?
What if it was 7 to 1/4
If this
times?
was like 5,
Yeah.
then you can't do anything.
Are we solving it from the 7 and
No, at this point, now if this was a number you could take the 4th root of or something like that.
Because in
You could do
the
this.
6.1, there was a lot of rounding to 2 decimals for like
Yes,
crap.
it just depends on what it asks for. If it just says simplify it, get it to the simplest form. If it says, it might say find the answer in round, then you would maybe type that in your calculator.
But for right now, we just leave it there.
Yeah.
Today is the 2nd, March the 2nd.
Yes.
What's March? That's crazy.
It's the 3rd month. I thought it was gonna be like 4th. Like March is the 4th. It was like not January, February, March. It's 3 months.
It's so close to April.
It's 3 months.
Yes.
Is that your birthday?
Yeah.
Yes,
Yay.
Don't say
Same.
that because that means our performance is
Y'all gonna
like,
turn 17?
Yep,
Oh, buddy.
17.
The 3rd, the 4th.
no, I know actually.
And then
I
Amos
don't
was
really-
the second.
Yeah.
Trey
It's
Witt
still
was the
stressful.
first. We just need the fifth.
First?
Spring break.
One April Fool's?
I'm probably gonna be
Yeah,
one.
Haley
you
loves
You
it.
gotta.
It's more like
really
you,
bad.
I'm more concerned
friend
about
whose birthday
sets,
is
lights, and
April
props. So if we
Is
do
that
anything
you
over
telling
spring
me
break, it's probably gonna be like that.
Well, I'm gonna
Her dad's
Well,
birthday is April
never
5th.
mind.
Now we just need April the 6th.
Y'all need to
From
be in
She's
a
the
row.
11th,
Y'all need to be in a
so
row.
we got.
Then
Then Sean is 24th.
Alright, in this
17th.
one-
Rachel's 17th actually.
In this
That was
one-
19th.
We have 2 different bases here in the parentheses, so we can't combine these together. So we can't do anything there. But this is multiplication and it's in parentheses raised to this power. So what rule could we apply to this?
Wait, what did you say?
No.
We actually apply.
Do it,
what
buddy,
you
on
said.
video, it's on
Say
video.
it don't work.
The fraction. We'll say that's
Yes,
what it's
yeah,
cost.
like we raise this to this power, right? And this to this power? Is that what you're saying?
I thought you just said they didn't have the same base.
You can't, I can't combine them, but I can raise each one of these to this power, because they're both in that. So, 6 to the 1, I'm gonna write it out separately. 6 to the 1/2 squared times 4 to the 1/3 squared. You're raising both of these to this power. I can't combine them, so I can't do that, but I can do this.
It's a little easier.
So when you multiply fractions, now you do have a fraction button on your calculator. At this point, if you don't know how to do this, I mean, you do have these pretty readily at your fingertips, right? Do y'all all know how to get to the fractions on here?
Math.
You can use-
Wait, hold on.
Yeah, you can use alpha y equals. That's one way to do that. Wait, no, is
When I
that
press alpha,
Yes, it is. Some calculators don't have it though.
okay?
mine's not
Math.
that.
And then you can also do, if you type in, like if I typed in,
Well, how does that work?
That
Alpha
would be
y
one.
equals, and then what happens?
huh?
The alpha y equals and what?
And then hit enter on that
What
first
about
one.
for dumb calculators?
Oh,
For dumb calculators. Alright, that one, I think if you go to math and,
Yeah,
no,
math.
there's another one where you can actually use it.
Do we have
Do you have
to-
that fraction? Scroll all the way over.
Do we have the whole thing in?
No.
No.
You don't have frac on there either?
Don't
It's
have
just
this.
frac.
I have this frac.
Yeah, you can do that. Hold on, let me see.
You just go to math. Oh, she has a.
Oh, you don't even have that?
She's a silver edition.
Okay, so what you'll have to do is you can do, like you
Oh,
could do
use
2
calculator.
times
This is the brown.
1/2 like that.
They're the
As
same
well as
type.
1. If you had a fraction answer like
I need
1
to charge mine.
times
I think about to die. It's like this.
2.
Yeah, I had.
And if you
my
wanted it
dad
as
was
a
dead for
fraction,
long,
then
and
you
I
can
finally
have
charged
I have
it.
a chemical
Frac.
tomorrow, so
Yeah.
You can definitely charge
What
that.
did you answer?
That's important.
Alright. So 1/2 times 2, that becomes 1. So 6 to the first power times 4, and then 1/3 times 2 is 2/3.
Wait, what the heck?
You want to leave it like that, or do we keep
Hate
going?
fractions.
So that's all
Wait,
you
you're
can
just
do.
Awesome.
What do you mean multiplying? How did the 2 1/2?
Because 2 is
So
over 1, so if you just
1/2
do it across,
times 2
Straight up multiply.
equals 2 over 2, which
It's 1.
equals 1.
Ah.
Wait, what are you doing?
You multiply straight across.
So 1/2 times 2 equals 1.
Oh.
Think about it, 2 halves.
in your
and then one
calculator.
third times two.
I love
Why
you.
would it
Or
be
you
2
just put that in your
6?
calculator.
Yeah.
Why wouldn't it be 2 6?
Okay,
so multiplying that by.
1/3 times 2 over 1.
Okay, never mind.
Yeah, you only multiply
That's like a
The top
fraction,
by
so
2.
it's gonna be.
equals 2/3. This, you don't make the mistake of trying to multiply 6 times 4. You can't do that because it has, they're each their own thing. This exponent is stuck to this. You can't separate it from that. So that would be your final. So we're running through all these different scenarios and different rules. You really got to understand these rules and orders of operations.
And then do we simplify that at all?
Nope, that's it. There's nothing you can do with that. If the 2 had been on the bottom,
Well, I mean, like, do we
put it in the
get it in
calculator.
a decimal form?
No, if not, if we're just trying to simplify. So, in your book, we're in 6.2. There is a chart here of all the rules. It's in like A, M, N, A, B form. But these are all the different rules, okay? If you need to like go back and check and figure out something. Okay.
Thank you, Jen.
Oh, you're welcome. Okay. Do we have the same base?
No.
No. So we can't combine them. But there is another rule that says if you have the same exponent, okay? Same exponent, we can do this. Okay?
Can you what?
With the negative 1/5 on the outside.
Yes, and then if you wanna,
Wait,
Lord have
if,
mercy.
since the 1/5 is negative, does that mean we have to put it all in a row?
yes, we'll do that at the end, very good.
Oh.
I hate
I always deal with the negative at the very end because it'll make it easy, like, to me, just to do that last, that's easier. So, we can go about this in a bunch of different ways. You actually could have, if you wanted to raise this to this power first, you also could do that. But I'm gonna put it all like this first. So, 4 times 3 is 12, right?
But you said we couldn't combine.
No, you can because they're in parentheses. You can combine these when you have the same exponent. See, these had different numbers and different exponents. Nothing we can do.
So 12 times
Yeah.
Can we do 12 to the 5th?
Don't do that first because that's gonna do this first. What's 5 to the negative 1/5? So what do we do with that?
Multiply.
Yeah, multiply.
Okay.
So 5 times negative 1/5.
Negative
Negative.
1.
Yeah, that makes it so much easier. It's just negative 1, right? So this is just 12 to the negative 1,
Which is 1/12.
which is 1/12. Yeah.
Math is
If you feel like this is hard, it is.
Okay.
This is always a very difficult.
Thanks for the warning.
Yeah.
Experience.
It's just a lot to remember.
a lot of little steps.
I'm just erasing this side. So let me real quick show you the difference, okay? So Bellamy she was like, I thought you can't combine them. So this right here, actually let me not put that in parentheses. Okay, different bases, same exponent, right? As opposed to, let's say like 2 to the 5th times 2 to the 3rd, okay? Different base, same exponent. Same base, different exponent. No got it? Alright,
Definitely.
so in this situation, you could put this in parentheses like this. You can do that, alright? This situation, you can add the exponents. So this would be 2 to the 5 plus 3. So here you put the bases together, raised to the same exponent. Here, you put the exponents together. Same base. Yeah, I know this is, but again too, if you need to reference this chart, this is in your book in 6.2, this might help if you ever need to this is something you can have with you on a test.
Oh, okay, yeah.
Yes,
Sweet. I was
yeah,
like,
like you can have that on your card and stuff.
Does it matter if we just do 8 or do we have to type 5 plus 3?
No, yeah, you don't have, I'm just in case someone was like, how did you get 8? I can show them. That's how I got 8, you add them, so then this would be 12.
I mean, technically though, if you put it in your calculator as 5 plus 3, it'd be the same answer. right?
Yes, as long as it stays up
Yeah,
here,
you gotta make sure
like,
it stays
it
in
stays
the
up,
thing.
yeah. Sometimes it'll do that and then jump down.
Yeah, if the number gets bigger, then it's adding only 3 to, or whatever the problem.
Yes. Okay, let's do another one.
The calculator knows what it's doing, as long as the inputs are correct. User error is
Is this just a better seating arrangement?
Mm-mm.
I like this.
I don't like it.
Because he can't see you.
I like when
This is better.
That's extra.
Or did y'all just not get up early today? Is that
No.
the difference?
This is the worst eating arrangement.
Yeah, we didn't get, I got up at like 7.
Yeah, that's
What?
that's the difference. He's still like half asleep.
Don't worry, tomorrow.
You're gonna make up for it. Okay. So what did you guys tell me was the rule when you have same base and you're dividing? What's the rule with the exponents?
Subtract.
You subtract. Subtract the exponents. So what's the invisible exponent here?
1.
A 1. All right. So that's a 1. Same base. So we can just do 5. And again, I'm just writing this extra step so you know what it is. So 1 minus
Wait, why is it
1/3.
minus?
Huh?
What's it minus? Because you subtract.
Because when you're dividing, you subtract the exponents.
Oh, it's 2.
So 1/1 minus 1/3. Again, if you can type, I'm always going to teach you this because it's good for you to know fractions. So we need the bases to be the same for subtracting. So I multiply this by 3/3. So this becomes 3 over 3 minus 1 over 3. Just subtract over the top.
How'd you get 3 over 3?
I multiplied the 1 times 3 over 3. Because you want to make the bottoms match when you're doing fractions.
Oh,
These
you
are
got
the-
large amount of
Yes, there you go. So this is just 5 to the 2/3. I can't take the third root of 5, so I'll just, that's simplified as far as I can go. One more in this section, just because you need lots of practice with these. Then maybe I'll give you some to do yourself. Let's see if, I'm gonna do these and see if you guys can, one more example.
Oh, all the way to E, whatever.
No. Okay.
Why would you do that?
Okay, so let's
That's
think
just a
about
pain in the
this.
butt.
Do we have same bases at all?
No.
So we can't apply that exponent rule of subtracting, okay? What is the same?
The 1/3.
Okay, so if you have the same exponent, do you guys remember what you can do if we got the same exponent?
You
If you
can-
have.
You can divide.
Yeah, I heard
Yeah.
good. I heard a couple of y'all say, so if we have the same exponent here, that means I can put the 42 over 6 like that,
And 1/3.
and to the 1/3, and then you can do a second set of parentheses, right?
And you do the 42 over 6 divided by,
Yes, you can do this, you can divide that, yeah.
but then you do 42 over 6 minus this. What do you do with the outer exponent too? Didn't you do something directly with 42?
We can get to that in a minute. Let's just start here. So let's do this. 42 divided by 6 is 7. So we have 7 to the 1/3, and then that raised to the second power.
So you get 7 to 2/3.
Good, Jack. So can't take the third root of 7, so we'll just raise that to the 2/3 power. And then so this is where people get tripped up, is knowing what to do sometimes here. So if that exponent is the same, whether you're dividing or multiplying, you can lump this together in parentheses, take care of that number, and then go on from there. I also could have, if you wanted to, you could have gone this route. You could have applied this first and done 42 to the 2/3 over 6 to the 2/3, and then combine them. 42 over 6 to the 2/3. You could go that way, you get the same answer. Okay, let me give you guys a couple to practice. You try these.
You don't have to, it's okay. No, we don't.
Yeah, we have a Bible verse next tomorrow.
Wait, what?
We got a chemistry test tomorrow.
I know, but I remember we also have a Bible verse.
The
It's
verse is
really
really
easy.
short,
It's like,
though.
yeah.
Yeah,
It's
it's
like
like-
2 lines, it's not that bad.
That's tomorrow though? Crap.
Mm-hmm. Like Proverbs something.
I thought it was Monday.
What else do we have? We
The
have
book review, he's doing this weekend.
book review. Oh.
No,
No, it's
March
due
6th.
Monday.
Monday?
Yeah,
Monday.
it's due March 6th.
What is?
The book
I
review.
don't know, the last
He
time-
said he could turn it in on Friday.
He moved it
On
to
his
Monday.
actual
I just like put March.
I wrote
Dude.
it later, like Friday, he said it, so I don't know for sure.
He changed it
Well, let's
online.
just see.
It's March 6th.
I know. They're not.
I'm gonna force them.
You're gonna threaten him backstage.
Oh, that looks fun.
to play Reckless Love. I
don't
care what
his field
I'll give you my Nerf gun. That one worked.
That was always Wilson and Elijah's like